Good afternoon to one and all present here with great joy and pleasure. Myself, Lakshmi Kanan from second year IT. I feel privileged to extend my warm welcome to all present here for essential of IP addressing in computer network organized by Association of Information Technology EXA. Associations are created to establish strength and unity working towards common goals in virtual every profession. Thank you. Now I request our HOD, Dr. N. Kanya ma'am, to give the welcome address.
Thank you, Yugendran. Good afternoon, everyone. It's my pleasure to welcome you all on behalf of the department and on behalf of the university to the international webinar on essentials of IP addressing in computer science, computer networks by Dr. Kamala Kannan, McCaps, lecturer, School of Technology, Asia Pacific University, Kuala Lumpur, Malaysia. I'm happy to welcome you, sir, to our university. We are very eager to hear about the essentials of IP addressing in computer networks from you, sir. We are very much interested in collaborating things, works and research with you, sir. We are happy to welcome you to our webinar, Mr. Kamalakanan. And I'm also happy to welcome all the participants whose work attending this the international webinar through our virtual platform through our YouTube channel. Welcome you all, and also I happy to welcome the faculty members of Department of IT and other participants who are attending the international webinar. I thank Ms. Padma Priya, who is the coordinator of the event, for organizing this in a great way. Welcome you all. On behalf of the Department of IT, we are very grateful to our Founder Chancellor, Dr. A.C. Shanmugam sir, and our Resident Engineer, Mr. Arun Kumar sir, for their constant support and guidance to us to achieve more and more success. Thank you, one and all. Welcome once again. I'm happy to welcome you all to this international webinar. Thank you.
Thank you, ma'am. Now I call Mr. Yugendran, second year IT, to introduce our chief guest. Good afternoon, everyone. I am honored to welcome today's chief guest, Dr. Kamalakanan Machar. He has more than 1 decade of experience in teaching in the field of computer networking and cybersecurity. Extensive experience, extensive experience in implementing security systems, network designing performance, security technologies, vulnerability assessment, and penetration testing. He is also a professional member in the International Association, Computer Science and Information Technology, Indian Science Congress Association, and International Association of Engineers. And, and Sir has completed PhD in Information Technology at Bharat University and MBA in Operation Management in Tamil Nadu Open University. And
Hello. All right. Thank you. Thank you to all of you. Given a short intro about me and also the today international webinar. First of all, I would thanks to the Dr. MGR University invited me for the international webinar. Um, Now let me share my screen to you all about to sharing the session. Mm. I believe that you all can able to see my screen. Hello, can you hear me?
With your lecture, sir.
Sorry, can you hear me?
Hello,
Yeah,
sir.
yeah, yeah,
Sir, you can carry on your lecture.
yeah. Sure. Thank you.
Okay, sir.
Let me
Okay,
know
sir.
how to share the slide in here because we are using currently Microsoft Team rather than using yeah, this one. Okay, all right. Thank you. Fine. Okay, fine. So just now before they give an intro about me, currently I'm working in a School of Technology in the Asia Pacific University. My major background is computer networking and cybersecurity, especially having a vast knowledge in the pen testing, how to handle the tools called Nmap, Multigo, Nessus and all. But in my today, the webinar is sharing the knowledge of why the IP address is the most important in the computer networks. And in today, our topic and the structure for the seminars or the workshop, IP addressing, and the range of IP addresses also available because we cannot generally say about only the IP address and the range of IP address, how the range of IP address is using for different areas like classifications. Not only the IP address using, when we are using IP address, of course, we should know about that the subnet mask, default gateway, next to who, destination network ID. And apart from that, there are a few devices I can add here. So first, I will explain you everything about that IP addressing until the point number before last. And the later on, I can show some hands-on how to design a network diagram by using Cisco Packet Tracer tools. It's a one kind of the simulation tools. All right. Okay. Let's we go to the session. Learning outcomes in this entire session, we are going to see about discussing and understanding the knowledge of the IP addressing and the subnet mask. Finally, I will design the network design by using the simulation tools Packet Tracer. All right. The first one is the most important. All are having a mobile phone, all are having a laptop, all are using internet. Without that internet, we people cannot able to do anything. Am I right? So when we are using the internet, of course, we should need to, sorry, we should do something. What is that we should do something? We need, if your device want to connect with the internet, of course we need an IP address. All right, every system have an IP address. Without that IP address, the system cannot work. How the seven kind of that OSI layer is the most important when the network is start to work. Similar like that, without the IP address, the system cannot work. We cannot identify that which system is connected to the network. So if you want to know that system IP address, if you want to know the system, we should find that IP address. So what is mean by IP address? We can tell everyone internet protocol address, but how that internet protocol address is working, that is the most important. So the internet protocol address is nothing but every system has a IP address, which is set by the system admin or network admin. Fine. That system has connected to the network. We need the network ID. So the network also having a name. So what I'm trying to say here, host ID plus the network ID should be worked together to bring us something globally connected. So without the IP address, the system cannot able to connect, able to share, able to communicate with others. So location and that identity, a network and the host. Host is our PC, our laptop IP address, which is connected to the network ID, both should be working up together. So this IP address having two versions. Version one is, the first version is 4, version 4. The second one is the version 6. So today we are going to see fully about that version 4, as well as we see some hands-on. Not a much thing about that version 6. Okay, right. This version 4 IP address is the 32-bit length. Every IP address has some kind of a bit length. So in that way, the version 4 is having a 32-bit length. Later, I can tell you, maybe in the next slide, I can tell you why the 32-bit length came. Why not we say a 28? Why not we say a 16? Why not we say a 32? 36, something like that. Okay, right. Now here, we should know how many numbers of IP address are available in the version 4. Just you can see total number of IP address equal to 2 to the power of 32. This 32 is nothing but the bit length of the version 4. So 2 to the power of 32 equal to 4.3 billions of IP address only available in our version 4. All right, 4.3 billions of IP address only available in version 4. Okay, fine. How the IP address starting? Just now I said a 4.3 billions. So these 4.3 billions from where to where? We should know that one. So always the IP address is starting, the version 4 starting with 0.0.0.0. This is the first IP address. Then the next is 0.0.0.1. Then next one 0.0.0.2. So the last field, this one goes to until 255. This one goes to until 255, which means 0.0.0.255. Then after the next IP address, have to focus the third one. So which means 0.0.1.0. Then the next IP address 0.0.1.1. Then the next IP address 0.0.1.2, 1.3. So this one goes to until 0.0.255.255. So the last two fill over. Now the second one. After that, again they start at 0.1.00. So that one goes to until 255. So which means 0.255.255.255. Then again they go to start with the first field 1.0.0.0. Right? So next is 1.0.0.1. So this one goes to until 255.255.255.255. All right. So totally 4.3 billions of IP address available. This is the last IP address 255.255.255.255. So the first IP address is 0.0.0.0 and the last IP address is 255.255.255.255. So totally 4.3 billions of IP address available only in the version 4. All right, fine. Now, the next, This is the small example I given here. Whatever you are looking in the blue color, the dark blue color is just assume a PC, and every PC has an IP address. So all these PCs are connected with the like something like it's a look like a sky blue or green color. It's up to you, whatever the color you want, you can keep it. So all the systems are connected with this network. So system IP plus the network IP should be work together. So whenever your system has connected to the network, of course the network ID should be connected with the system. Then only it has able to get the any of the signals or data from the internet. So for that sake, I've given a small image here to understand how the network is connected with the IP address. Now, I come back to the IP address. You can see there are 4 octets available. 4 octet, octet 1, octet 2, octet 3, octet 4. All right. So just you can see in each octet, they have 8 bits. The small box is a 1 bit. So 1, 2, 3, 4, 5, 6, 7, 8 bits are available in each octet. All right. So totally 4 octet. So in each octet, 8 bits. 8 times 4, 32 bit. So if I'm not mistaken, here I said 32 bit, right? These 32 bit came from like this. Each octet has a 8 bit, 8 times 4, a 32 bit length of IP version 4. All right. Now, let me tell you about something, whatever the highlighted with red color, the numbers 1, 2, 4, 8, 16, 32, 64, 128. All this value is called as a place of value. All this called as place of value 1, 2, 4, 8, 16, 32, 64, 128. We cannot change it. All right. So here, just you can add all this value 128 plus 64, 192. 192 plus 32, 224. 224 plus 16, 240. 240 plus 8, 248. 248 plus 4, 252. 252 plus 2, 254. 254 plus 1, 255. So each octet has 255 uh, bits having. So 4 octet, 4 times 8, 32 bit length, and each octet having a 255. Okay, what we'll do by using this? Very simple. The system has always considered either zeros or ones. In the keyboard, we have A to Z letters, but whatever we are typing, the system couldn't understand what is that. It should be converted into either zeros or ones. If I'm not mistaken, you people know about that the binary conversion, decimal to binary, binary to hexadecimal, decimal to hexadecimal, right? So when you do all these conversion here, the system can consider either zeros or one. So what we have to do here, just you apply zeros in all the bits. Just you apply zeros in all the bits. 1, 2, 3, 4, 5, 6, 7, 8. In all the bits, you apply 0. Same thing you follow in the second octet, third octet, as well as in the fourth. All right. When you apply 0, whatever the place of value is given in the bit should be considered 0. When you apply 0 in all the bits, the place of value considered as a 0. When you apply 1 in all the bits, the place of value should be considered. The place of value should be considered. Let's say in 128, if I apply 1, I should consider this 128. Let's say example 1. The 64 I applied 0, 32 I applied 1, 16 I applied 0, 8 I applied 1, 4 I applied 0, 2 I applied 1 I applied 0. So wherever there is a 1 and I look at the place of value, then I need to add the value. So 128 plus 32 plus 8 plus 2, I need to add all the place of value. This is the system has to. So wherever you apply 0, just you leave it. Wherever you apply 1, you must consider the place of value. So here we have to apply either zeros or 1. So when you apply 0, all should be 0. When you apply all 1, please you add the entire total value. So here 255 come, then dot 255 dot 255 dot 255. So the last IP address 255.255.255. The first IP address you can consider 10 from 1 output. So 0.0.0.02 until 255.255.255. So this is the IP address starting to end. All right. Now, next, the classification of the IP address. You should know about the classification of IP address. Totally, 5 classes are available. A, B, C, D, E. Here, each classes has some network bit as well as a host bit. This 32 bit is the default one for the version 4. All right. So when you take the class A, you may ask me, so how could I know about that given IP address belongs to class A? The one I can tell you in the next slide. First, let me explain you about, based on the given IP address, how to find out the network bit as well as the host bit. In the class A, you have to find the first 8 bit goes to network. The remaining 24 bits goes to host. So how could we know? Very simple. The first 8 bit is nothing but 1, 2, 3, 4, 5, 6, 7, 8. The first octet. All this first octet goes to network bit. Then the remaining second octet, third octet, fourth octet, which means 8 plus 8 plus 8. The 24 bit goes to host bit. So 8 plus 24, 32 total bit length we got for the class A. Next is the class B. So the class B, I given here 16 network bit, 16 a host bit. So here 16 means we have to consider the first octet and the second octet. 8 plus 8 or 16 bit goes to network bit, and the third and fourth octet bits goes to host bit. So 16 plus 16, 32 bit goes for class B. Then the class C, first octet, second octet, third octet, all the 3 octet bits. So which means 8 plus 8 plus 8, 24 bits goes to, 24 bit goes to network, and the last fourth octet 8 bit goes to host. So 24 plus 8 are 32 bit. So class A, 8 network bit, 24 host bit. Class B, 16 network bit, 16 host bit. Class C, 24 network bit, 8 host bit. Class D are using for multicast address. So we don't bother about that class D. And class E are using for reserved for future, but currently they are using for defense purpose in many countries. So they won't touch the class E. Most of the organization they can use about the class A, class B, class C IP address. All right, fine. Now you can see the classification of address here, class A until class E. So the class A first byte or first octet goes to network ID. The green color highlighted is 8 bits. Then second octet, third octet, fourth octet goes to host bit, which means second octet 8, third octet 8, fourth octet 8. 8 times 3, 24 bit goes to host ID for class A. We should remember this one. If you are not perfect in this area, then we may get a little bit confusion about how to find the range of the IP address. So we should be aware of how to find the network ID and the host ID for the given IP address. So class A means 8 bit goes to network, 24 goes to host. Class B means 16, 8 plus 8 goes to network. Then third octet, fourth octet, 8 plus 8, the remaining two octet goes to host bit. Class C, all the first three, octet 1, octet 2, octet 3, all these three goes to network bit, and the last one goes to host bit. All right, then class D, already I told it's a multicast address. Class E using for defense purpose. Here we should remember one thing. We should remember the zeros, 1 0, 1 1 0, 1 1 1 1 0, and all the one. Why? Because by using this value, we are going to find the range of IP address for each classes. So class A 0. So class A 0 means you can able to see here the range of IP address. You have to take any one octet. You have to take any one octet from the 4. I am consider here always the first octet. So in the first octet, the place of value should be that there is no change. 1, 2, 4, 8, 16, 32, 64, and 128. Here supposed to be 128, but I applied 0. Why I applied 0? I applied 0 taken from here. Taken from here. So I applied 0. So what you do, the condition is the system can consider either 0 or 1. So first you can apply 0 at all the place of value. All the place of value. When you apply 0 at all the place of value, 0 times 0, anything is 0, right? So we put a 0. We put a 0. Next, the second condition, we need to apply once. So you apply once at all the bits except the last one, because the last one already we assigned a 0. Here supposed to be 128, but we applied 0. Right? The remaining place all you apply once. When you apply once, just you consider the place of value and add all the place of value. So 64 plus 32, 96. 96 plus 16, 106, 112. 112 plus 8, 112 plus 8 or 120. 120 plus 4, 124. 124 plus 2, 126. 126 plus 1, 127. So we got that 127. So the range of IP address for the class A 0 to 127, but we are not say 0 to 127. We must tell the full IP address range 0.0.0 to 127.255.255.255. We should not tell 127.0.0.0. The 127.0.0.0 is the first IP address for the 127. What is the last IP address of the 127? This one, 127.255.255.255. So the range of IP address for the class A is 0.0.0.0 to 127.255.255.255. All right. So this is the class A. Now let me go to the class B. You can see here, this is the class B. Again, I taken any one octet and there is no change in the place of value, but the last 2 bit I applied 1 and zeros. Why I applied 1 and zeros? From here, I taken from here 1 and zeros. So after I apply 1 and 0, immediately I should remember in my memory, always 1 means we should consider the place of value. So here the place of value is 128. When you apply 0, just you forget about the place of value. All right. Then what is the third condition? Please you apply all the bits 0 except the last 2. But here we applied 1. So we must consider the place of value is 128. You take the 128 here. Fine. Then later on, you apply 1 at all the bits. So here, first is the 128. The next one is 0. Just you leave it. Then the third one, we apply 1. So we must consider the 32. 128 plus 32 is 160. Then 160 plus 16, 176. 176 plus 8, 184, plus 4, 188, plus 2, 190, plus 1, 191. So the range of a class B IP address is 128 to 191, but we are not tell that 128 to 191. We supposed to tell 128.0.0.0 to 191.255.255.255. 255. So this is the class B, a range of IP address. Now next is the class C. In the class C, again I applied 110, not the same value. We need to consider this class C, 110. So what we do here, again in the same condition, when you apply all the zeros, just you leave it the place of value. Then wherever there is a 1, please you consider the place of value. So 128 plus 64 is a 192. Then later on, I apply once at all the bits. So when I apply once at all the bits, the third bit I should leave it. Then I should consider all the remaining bits. So which means 128 plus 64. 128 plus 64, 192. 192 plus 16. 192, 202, 208. 208 plus 8, 216. Then 220, then 222 plus 1, 223. So the range of IP address is 192.0.0.0 because that is the first IP address for 192. Then what is the last range of the IP address for class C? 223. And what is the last IP address? 223.255.255.255. All right. So this is the range of a class C. Then the class D, we need to apply a 1110. So these are 1110 I taken from class D here. Then again same, you have to apply 0 at all the places. You have to consider only wherever you applied 1 and the place of value. So the first one is a 128 plus a 64 plus 32. We got a 224. Then the last IP address 239. Except the fourth bit, we must consider the place of value 239. So the range of a class D IP address is 224.0.0.0 to 239.255.255.255. This is the class D. Then the last class is E, and I applied all is a 1. All right, here I applied all is a 1, which is showing in the red color. All right, so the remaining place you apply 0, then you consider all the place of value 0, and wherever you applied 1, consider the place of value. So 240. 128 plus 64 plus 32 plus 16, 240. And the last one, you apply all the bits equal to 1. So then you can consider the place of value, or we get a 255. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, 255. So the range of IP address for the class E 240.0.0.0, and the last IP address is 255.255.255. So we got a range for each and every classes. So the starting IP address, coming back to here, the first IP address 0.0.0 and the last IP address 255.255.255. So between these, the IP address version 4 has been divided, they classified according to the class, they set the range. So each and every IP address having some classes and having some network bit, also a host bit. We should not forget about this range of IP address. In case if they ask you in the midnight or 1 o'clock or 2 o'clock, what is the range of a class C? Of course, you have to tell. If you are strong in that IP address, then it's very easy to do the IP address calculation, setting an IP address for the network diagram. Okay, fine. Now, this is the small example given in the table. Here, we saw a few classes, a range, class A, class B, class C, class D, and class E. Each classes has some range of IP address. So, how many numbers of IP address available in each classes? Let's see, class A, prefix length is nothing but the network bits 8. And what is the range? 1 to 126. 1 to 126. What is the meaning of the star here? You can see the addresses starting with 127 is reserved for a local host. So they won't touch that one. You can use the 127 as the IP address in the method. All right. So that is the first range of IP address for the class A. Then you can see here number of a host address 2 to the power of 24. How this 24 came? I told you right. The total bit length of the version 4 is a 32 bit. In the 32, 8 goes to prefix length. 32 minus 8 remaining 24. So 2 to the power of a 24 minus 2. What is this minus 2? The minus 2 is nothing but the first IP address 0.0.0.0. That is called as a unknown IP address or invalid IP address. 0.0.0.0. Then the last IP address 255.255.255.255. That is called as a broadcast address. We have to minus the first IP address and the last IP address. So after we minus these two, 2 to the power of 24 minus 2, we can get these much IP address only goes to class A. You see how much IP address available. Then the next is the class B. The class B prefix length 16. The total bit length of version for IP address is a 32 bit. In the 32 bit, you have to minus the 16 bit. Then the remaining is a 16. So 2 to the power of 16 minus 2, we got a 65,000 plus IP address. And there is no doubt in the range for the class B. Then the class C, 24 bit goes to prefix, which means the network bit. And the remaining 8 from the 32, 24 goes to network bit. The remaining is 8. So 2 to the power of 8 minus 2, we have a 254 IP address in class C, and this is the range. But the class D and E doesn't have any of the ranges. Most of the places they are using a class B, class A IP address for their organization or systems. So this is the way they can divide it, they can set about what is the number of host address available according to the classes. Fine. Now next, this is the smaller example. Whatever we have discussed, based on that, here they are given class A starting IP address, ending IP address. So whatever the red color with the highlighted in a green color background is the network bit. You can see here, which means first octet 8 bit. The remaining 3, 8 plus 8 plus 8, 24 bit goes to host. For which class? Class A. Class B, 128.0, which means 8 plus 8, 16 bit goes to network ID. The remaining octet 3 and 4 goes to host ID. Same here. Class C, the first 3 octet, which means 8 plus 8 plus 8, 192.0.0 goes to network ID, and the last bit goes to host ID. That's all. So this is the range just I want to show you. Now, so far we are discussed about the IP address. Next is the subnet mask. When you type the IP address in the system, the next column you need to do the subnet mask. Basically, if you are using IP address, when you press the tab button, automatically it goes to the next box and it will display the subnet mask. Later I can show you some demonstration. What is mean by a subnet mask? Basically, here the subnet mask is, we can tell in a one line, it always determining about that how many network bits available for the given IP address. Let's say example, you can see 10.0.0.10. So you should remember this is the given IP address. By given this IP address, you should know first what is the class. So 10.0.0.10 means, you should remember 10 means class A. 10 means class A. That is the first step. The second step, you should think about, okay, class A, then class A means how many network bits, how many host bit available in the class A. 8-bit network, 24-bit host, which means first 8 bit is the network bit. The remaining 8 plus 8 plus 8, 24 bit goes to host. So here we should think about the first 8 is goes to network bit. The remaining all the 3, 8 plus 8 plus 8 goes to host. So in the subnet mask, wherever there is a network bit, please you have to apply 255. And wherever there is a host, please you apply 0. This is the shortest way we have to do the subnet mask. So the given IP address is example 92.1.24.74, 92.1.24.72. You don't bother about any octet, just you look at the first octet. The first octet is 92 means immediately we should think about 92 belongs to which class? Class A. Okay, class A means how many network bit? 8 network bit. How many host bit? 24 host bit. Okay, if you want to find the subnet mask for the IP address, so the first one is a network bit. So wherever there is a network bit, we should put 255. Wherever there is a host bit, we should put 0. That's all simple. So here I put 10 means network bit 255. The remaining place all I put 0. This is the first example. The second example 178.45.87.10. So the alignment a little bit more. I apologize for that one. So 178.45.87.10. So the 178 means we should think about which class. This is the class B, because the class B range is 127 starting, right, and finished by 192, right? So 178 coming in between these range. So class B. So class B means how many network bit, how many host bit? 16 network bit, first octet and second octet. So 16 network bit. Third and fourth octet goes to host bit. So third step is wherever there is a network bit, we need to put 255. So 178 network bit, put 255. 45 is the network bit 255. The remaining 2 bits you put just a 0. So class B means subnet mask is 255.255.0.0. That is the class B. Now class C, what you're looking on the screen is the class C. So the 200 is the range of a class C. So here how many network bit? 3, we cannot say 3. 3 octet, 8 plus 8 plus 8, 24 bits. So wherever there is a network bit, just you put a 255. Wherever there is a host, you put a 0. So if any of the given IP address is class C, just you put the subnet mask is 255.255.255.0. All right. So class D and class E, don't bother about that one. So class A, class B, class C, you must remember. All right. And whatever we are discussed about the subnet mask is called as a default subnet mask. Default subnet mask. There is a changes in the subnet mask. We are not focusing that area in this session. Okay, so just now we discussed the IP address and subnet mask. Now, this is the example of that given IP address subnet mask. Normally, I'm not sure about their how they are given, how they prepare the question which are related to the IP address topic. Here, normally we will we will give IP address. So based on the IP address, you should find the class, you should find the subnet mask, you should find the network ID. Here I didn't include the network ID, just I stop until the subnet mask. Okay, so these are the given IP address, and according to the IP address, you should find the class. Once you know the class, is easy for enter the subnet mask. Class A means 8 network bit, 24 host bit. Wherever there is a network bit, put 255, finish. Wherever there is a host bit, put 0. So class A, finish. Class B, 255.255.0.0. Class C, 255.255.255.0. All right. So this is the small example. Right now, the next IP version 6. So far we are discussed about that IP version 4 as well as the subnet mask. The IP version 6. We are not going to use the IP version 6 in the hands-on session. We are going to just I want to brief you about the version 6. Basically, it is the 128-bit length. The IPv4 is a 32-bit length. You see, version 6 is not a double, triple than the version 4. All right. So 128-bit length. So how many numbers of IP address available in the version 6? 2 to the power of 128 equal to 3.4 trillions of IP address available. But version 4, how much IP address? 4.2 billions of IP address. 4.3 billions of IP address in the version 4. But in the version 6, you can see 3.4 trillions of IP address are available. All right. Then these IP address divided equally. From that 128, 64 goes to network bit, the remaining 64 goes to host bit. There is no changes, class A, class B, class A. It's not like that. The version 4 have a classification. IPv6 doesn't have that kind of a classification. Then in the version 4, according to the classification, they set the range of IP address, they set the range of network bit and the host bit. But here is not like equally divided. Out of 128, 64 goes to network, another 64 goes to host. That's all finished. Now you can see here version 6. The another name of version 6 called as colon hexadecimal format. Why they call in a colon hexadecimal format? You look at the example below I given here, 2A03, all right, blah 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 blah, they're given, right? So this one is a one IP address taken from the Facebook systems, all right? So here 2A03, so hexadecimal is already included. Because of that, they call a colon hexadecimal format. But the version 4 is called as a dotted decimal format. That one is a very simple one, the IP version 4. Okay, right. Now, let we go to see how the 128-bit length came. This is the structure of the IP address. And I believe that this is the last slide. After that, we are going to see the hands-on. The structure of the IP address. Here, it's a 128-bit. How the 128-bit length came for the IP version 6. Totally 8 blocks. Totally 8 blocks. I think these block also alignment are moved. I don't know what happened after I share here. The alignment a little bit changed. It's everything is perfect before I share here. Okay, this is a matter. Here, totally 8 blocks, and each block has a 4 hexa. Each block has a 4 hexa, and each hexa got a 4 bit. So 4 plus 4 8 plus 4 12 plus 4 16 bit, which means each block has a 16 bits. 16 times 8, 128 bit length of IP version 6. Okay, now let me show some example. Here I want to say something here. You can see here 2A03, all right, colon 288 colon 2110 colon DF07 colon FACE colon BOO BOOC colon 0 colon 1. Here why they put a 0 and 1? Why not they put a 0, some name, number, some kind of that hexa? Why they didn't put? Which means this 0 is indicating about 0 0 0 0. In IP version 6, if the continuously 4 decimal got a 0 0, then they can consider only a 1 0. And somewhat the next one also is starting at 0 0 0 1, means it consider only that value of 1. So these kind of things are using in the IP version 6. All right, now I want to go back to the network device. That's all about the IP version 6. What you are currently looking here is that network devices which are related to the Cisco's. And what you are looking on the left side, this is looking like a room, I mean a network connectivity room. Yes, we have our organization having this kind of a setup using for the student purpose. All right, we have a separate routers, switches, servers, cyber range for the cybersecurity, networking, a server room for the Cisco network lab. And what you are looking here, the other one is the switches are connecting all the places. Okay, so just this one is the example. Just I want to show what is that switches, what is the router. If I'm not a mistaken, the switches is always we call this receiving the data or packet and forward to the next level. The router is always dominating the network, is how to say, um, it's a dawn for the network, and it can receive data from over the network and send into the inside the internal device. That is the router. But in the router, basically all the routing concept has been used. If I'm not mistaken, in the 7 OSI layer, the network layer is mostly using all the routing concept. Let's say example, today morning you want come to work for the university. So you came out from the house, you are starting your car, just you start the car. After you start the car, just you are thinking which is the correct route that we can take and go to reach the university. So you have to decide which route you want to go. Multiple routes are available, but which route you want to go and reach to the university. I mean, you reach to the destination. You have to think. Then, once you think, you have to start the car and you can go to use the route and reach the destination. Which means what I'm trying to say in the routing concept, first it will make exact path to the destination. All right, it will find the route and make exact path to the destination. Then after start to send the data. This is the routing concept. There are all kind of a routing protocol using here. There are plenty of protocols that I believe that you may already have studied, like OSPF, Open Shortest Path First Protocol, Interior Gateway Protocol, Exterior Gateway Protocol, Border Gateway Protocol, RIP, Routing Information Protocol, and in the transport layer, they are using two types, TCP, UDP, you may have studied that one, and plenty of SNMP, SMTP, ARP, Address Resolution Protocol, Simple Network Management Protocol. All right, plenty of protocols is available, but depends upon the situation, they can use some of the protocols. All right, so now the next is, I think, is a Q&A session. Before starting the hands-on, any questions so far from the audience side? You can ask me, or else you can tag in the box where available here. So give me a few seconds. Let me go to share the packet tracer tools to show the hands-on. Give me a few seconds. I believe that you all can able to see my screen. Please give me a response. I think you can able to see my screen, right? The current one is the Cisco Packet Tracer. If anyone is in the online, please give me your response. Hello? Anyone is there? Hello?
Hello,
Yeah, can you hear me, madam?
sir. The students are watching in laboratory, sir. They can't hear your. They can't
Okay, fine.
respond to your questions.
All right, fine. How about
You can
they can
continue
able
with them.
to see the simulation tool Cisco Packet Tracer? Just
Sorry.
I want to know whether they can able to see the Cisco Packet Tracer, the simulation tools from my side.
It's not visible, sir. It's only Q&A session. That screen only visible.
Just now I share the screen. Hold on. I need share the screen. Okay, fine. Windows. Okay, Cisco Packet Tracer. Now the student can able to see the screen. Cisco Packet Tracer. It's a simulation tools. Whether they can able to
It's
see.
not. It's not visible, sir.
Okay, hold on.
Visible.
When I click the entire screen, automatically the student can able to. How about now, ma'am?
Sir, tell me, sir.
How about now? Are they able to see the Cisco packet tracer,
It's
the,
it's
the
not
screen?
visible. No, sir. It's not visible.
Now, madam?
No, sir.
Actually, in my side, yeah, it's showing. Already, I shared the screen, the simulation tools. Please kindly check with the
Check.
students. Are they able to see on the lab system? Ask them to check, ma'am. Please, I'm waiting for your response. Yeah, fine. All right, fine. I think now they can able to see. Am I right, madam?
Yes, yes, sir. Now it's opening. You can
Okay,
continue.
all right. All right. Thank you. Okay, all right, fine. Thank you for the response from your side. What you're currently looking is the Cisco Packet Tracer, right? Why you got a pen? Why I cannot able to? Hold on, huh? I cannot able to access. Why? What happened? It's supposed to be come. Ma'am, kindly check now because previously, yes, it was displayed, but I cannot able to operate or access anything. How about now?
Now it's opening, sir. You can continue.
All right, fine. Thank you. Now the students all can able to see my screen. I believe that. Okay, fine. Okay, thank you, students. Thank you for being patient. Now, what you are currently looking here is that simulation tools, which is called as a packet tracer. The one is designed by Cisco. Basically, Cisco is the network device related company. They have a lot of plenty of Cisco routers, switches, many things they are having. All right. Now, here, what I'm going to do, just you can see all the top side is like how when we open a Word file, we can see a file edit, blah, 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 something, right? So something they're given here. The second line all is about the save, zoom in, zoom out. The third one is each and every button has a different functionalities. So I can explain you when we are doing all this. And now you can see the bottom here. What you are the bottom on the left side, the first one is the network device. What you're looking here all is that the routers. So each and every router have some serial number. All right, you can able to see 4331 or 4322 or 194. So which means every routers have some common basic functionalities, and apart from that they have some special functionalities also. So it depends upon our requirement, we can use the devices. That is the first one. The second one is switches. There are few switches available. We can use accordingly, same similar like routers. The third one is the hub. I believe that you all know the difference between the switch and hub. So I can tell in a one line, switch is a single input, single output. Hub is the single input, multiple output. That's it. Okay. Then the third one is wireless devices. There are plenty of wireless devices out there. Maybe in your university, if you access the Wi-Fi, of course we need access point. All right. So here we can able to see a lot of access point along with the wireless routers. Then the third one is the firewall, and the fourth one is that a cloud. Okay. Here mainly we are going to use the router and the switches. Then you can see after the network device, you see the second one is the end device. When you click the end device, you can able to see the PC, laptop, server, printer, IP phone, TV, tablet, many things are there. So according to our requirement, we can able to use all this. Then in the bottom one, next is home appliance. Home appliance is, you can see aircon, fan, smoking detector, speaker, night lamp, RFID reader, webcam, many things are there. Then for the second one is the smart city. So if you want to use the IoT devices, we can take it from here. All right. The third is the industry. Fourth is the power grid. We don't want to use this one. Third and fourth. Who will use? In case if the electrical engineering student want to use anything, they can go for this. All right. Then the next is the component we don't want to touch here. The fourth one is the connection cable. If I'm not mistaken, you may have studied in the computer networking a few types of cable. All right. So we can use a serial cable, fast Ethernet cable. It's a depends upon the system connectivity. We can use all these cable. The first one is the automatic one. Second one is the console cable, the sky blue one. The third one, black color, is the copper straight through cable. Fourth one is the copper crossover cable. Fifth one is the fiber cable. Sixth one is the phone cable. Seventh one is the coaxial, the blue color. The red color with symbol is the serial DCE. The next one, only the red color is the serial DTE, data communicate equipment, data terminated equipment. The green color one is the octal cable. Then the before last one is the IoT customs cable, and the last one is the USB cable. Finish. From here, we are going to use only the automatic cable, or else a cross a copper straight through cable, and for connecting between the routers we will use a serial DCE cable. That's all right. Okay, fine. Now just image by yourself, there is a one organization. So that organization want to set up a network. Just image by yourself, you are the network engineer, you are working in a one company, you got a client. So the client is approaching you, hey guys, this is the scenario. We need a topology and designing network by using any of the simulation tools. So the scenario is nothing but they want CEO, all right, CEO, CTO or CIO want to connect with the one network, put it in a one block, and in the other block you can put the manager, a research lab, everything in the other side. All right, so please come on, you have to make everything and set up the network. Let's see whatever I said, the CEO, CIO, CTO, all right, all it's one side. Then the manager and the what do you call the research team, all it goes to in the another block. So totally two block. So what I'm going to do first, I'm going to select the router. So here, which router I'm going to select? I'm going to select the PT router. So where is the PT router in this line? You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to 1. You may ask me why you should select the PT router. Why not you select 2911? Yes, we can select, but some of the router doesn't have a appropriate port, because some of the port has some kind of a functionalities. It has been worked accordingly. So I'm taking a router PT. So two block, I told you, right? So again, I'm taking a second router PT, and I given the name here. I'm going to given the name here. Sorry, so here, what I said, this is the block. Better we can put we don't want to put only a block. CSK. You're going to IPL going to open very soon, right? Okay. This side is CSK. Okay, this side block. We can put RCB. Okay, fine. Now, so whenever I click here, if I wrong select anything, I will click here. Okay, fine. Now next is next switch. You go to the switches. You can select any switch, but here I'm going to use the first switch or either last two switch. Okay, I taken one switch. Okay, fine. Then taken before last switch here, and one more switch here. Then again I'm taking one switch and put it here. So this is for CEO, CIO, CTO. CEO is nothing but Chief Executive Officer. CIO is the Chief Information Officer. CTO is the Chief Technology Officer. So all these three goes to here. So what they have a PC. So click here, go to laptop, not PC, laptop. CIO, CTO, all these three. Okay, what for this? What for this? This one is a router room. So I'm sorry, server room. I'm going to take the server. I'm going to take the server. All right, to server. Then I want to monitor the server. So I need a CCTV. So where to get the CCTV? You go here, you see webcam. Take the webcam. Then The server room is a most secured area. I want RFID. I want RFID. Without RFID, we cannot access or enter inside. This is the RFID. Okay. So these three is CEO, CIO, CTO. It's up to you. Whatever you want, you can keep and put the name. CEO, CTO. Right? Then this one, CIO. Finish. Alright, then here server, we don't want to change the name for the server. Alright, so for all this comes to one network, this entire server room. Then the other side, taken a PC, one laptop, and one printer. Okay, then technical people should monitor and control the server room, even though which is in the different block. So for the technical person, of course, they need a PC or laptop. Okay, and this is the manager room. One manager is the very old person. He doesn't know how to handle the laptop, so we put a PC. The other one is the young guy, all right, a guy or girl, so they know how to handle the laptop, so we put a laptop. But of course, we need the, what do you call, the printer. Okay, the CCTV camera, all RFID is called as the IoT device. Wherever is necessary, you can put it. Fine. Now, what is the next? The next is the cable. Here, if you want to connect PC to switch, you should go copper straight through cable. Select the cable, go to laptop, CO, right click, you see fast Ethernet, select, go to switch, right click, you see each switches has a 24-bit fast Ethernet port, 24 fast Ethernet port available. Okay, so you can select and connect with any one, doesn't matter. So always I'm going for order connect. Then again you select the same cable, connect CTO to switch, then CIO. Finish. Okay, right. Now again you select the same cable, click the switch, connect to the router. Fast Ethernet, you have to connect with fast Ethernet only. Then go for the second, server. Okay, so here, hold on, let me say something to you about the webcam. This is the Cisco packet ratio version 8.2. So the 8.2, if you want to use the webcam, double click, all right, you should go to physical, you go to here, then you can use the adapter. Click the advanced, you go to IO input output config, network adapter. Here you need to select 1CFE, all right. Then after, power on. Yeah, power on now. Fine. Now you can see fast Ethernet, we got the port. Finish. Previously, we didn't see the fast Ethernet port. Fine. Now, next, we can connect from here to the router. We can able to see the auxiliary port, console port, fast Ethernet port, serial port. You have to select the fast Ethernet. Then you may ask me, why there are two different types of fast Ethernet? You have to select always this fast Ethernet. Okay, the fast Ethernet gigabit is there, normal one is there, so you have to select this one. Finish. Now, next you go to the opposite side, do the same thing. Then for the next department, so we almost completed the designing part. So what is the next? Now, yeah, I need to connect this one to here. Finish. All right. So next, I want to make something. What I want to make something, I want to give some coloring to easily understand. So what I'm going to do, fill the color, select the color. CSK is yellow, right? This time. Okay. Don't mistake me, huh? Okay. The shape. This is the shape. Okay. So now, the color look like, right? CSK. So next. Let me go to our Indian cricket team color, sky blue. This time I don't know what color. They have a different blue. So don't mistake me. Again, I'm using this one. Okay, for the other side, let me go for something a pink color. I'm a little bit weak to choose the color. Don't mistake me. Okay, fine. So now here we are select the device. All right, we want to set the IP address for every devices. How many days we can call see, if you have a new baby birth on your home, how many days you can call a baby boy or baby girl? We should keep some name, right? So now naming ceremony. So what I'm going to do, I'm going to set the IP address for every devices. So how to set? You see the symbol here, this is the box. Just you select, come to here, IP address. Then what is the IP address? I'm going to select the class B, 192.168. This one goes to 10. You can give any number, doesn't matter. Okay, I can go for 1.2 is the IP address. Then gateway. Okay, this is the default gateway. Later I can tell you what is that gateway. So the gateway is 192.168.1.1. So this is the every system need a IP address. So the second one is 1.3, but there is no changes in the gateway. There is no changes in the gateway. The third one is 1.4. Finish. All right. So now here I'm changing the IP address as well as the default gateway. 2.2, 2.1. And for the second server, also 2.1 is the gateway, 2.3. Then for the webcam, 2.4. For the RFID is a 2.5. Finish. Okay, then I go to the opposite side. Here 3.1 and 3.3. Then, sorry, this one is a 3.2, 3.2. 192.168. This is 3.2 and this is a 3.3 and this printer is 3.4. Then I go to the technical team 4.2. You can set any IP address which is related to the classes, class A, class B or class C. It's up to you. 4.3. Okay, fine. So now let me arrange it accordingly. Okay, then the next is network ID. Network ID for the CU office, right? So 192.168.1.0. Always the last octet should be 0 is called as a network ID. So this is a CEO. Okay, we don't want to give any name. Okay, right here. This one is a 2.0. Maybe this one server room. We can keep a server room. This one technician room. The network ID is 4.0. We have to follow the 4 series all goes to the technician room. And this one we can keep a research room. So the network ID is 3.0. Fine. So these are CO. We can put big boss room. Huh? You all like a big boss, right? Big boss room. All right, fine. So now finish. Now, what is the next? The next, you need to set the gateway here. Gateway 192.168.1.1 is the gateway for the big boss room. And 2.1 is the gateway for server room. 4.1 is the gateway for technician room. 3.1 is the gateway for research room. Okay, right. We given the number. Now what is the next? We need to assign inside the device. Just you click the laptop. I believe that you all can able to see the laptop. So inside the laptop, you go to desktop, go to IP config. Very simple. You can type the IP address 192.168.1.2. All right, so that is the IP address. Press tab button, automatically you can get the subnet mask. Press one more time, it goes to default gateway. The default gateway is a 1.1. So assign the IP address for CEO laptop. Next is the who is the next CIO. Again, you go to desktop IP config. So the IP address is 1.3, then 1.1 default gateway. Finish. Then the third one is go to desktop, go to IP config, then 1.4. We need to type the IP address accordingly what you are given here. Then the default gateway is 1.1. Finish. All right. So we done all the IP address for the big boss room. Then you should go to the router. Click the router. What is the IP address? I mean, what is the default gateway for the big boss room? 192.168.1.1. So you go to router, you find where is the interface FA0/0. You go and you find FA0/0, make a port status up, then it's immediately become a green color, which means the gate is open. Then you type the IP address 1.1, finish. Then the second one is the server room. What is the IP address? 2.1. What is the interface? FA1/0. Select the FA1/0, make a port status up. Then here you can type 2.1, finish. Close it. Now you come to server. The server, go to desktop, set the IP address. So what is the IP address? 2.2 for the first server. Then the default gateway is 2.1. Okay, 2.1. So you have to set the IP address default gateway for all the devices. 2.3, then default gateway. So the webcam also same. Click the webcam, go to fast Ethernet, set the IP address is 2.4. Then where is the, how to say, the default gateway? The default gateway is here, 2.1, finish. All right. Okay. Then next, RFID. So RFID, you go to config. The default gateway is a 2.1. Then you find the interface. You type the IP address is a 2.5. Finish. We assign IP address for entire block A. All right. Now move to block B. Device. Desktop. What is the IP address? I think a 3.2. Then 3.1. Go to the next laptop. Desktop. IP config. 3.3. 3.1. You need to do more hands-on here. Then config. Gateway is a 3.1. The Ethernet, the fast Ethernet is a 3.4. Fine. All right. Now next. PC desktop. So this is the technician room. What is the IP address? We are given a 4.3. The next one is desktop IP config 4.2, 4.1. Fine. After that, go to the router, click the router. All right. So in the router, you have to go to config. In the config, you find the interface. FA1/0 belongs to technician room. Make a port status. Immediately it becomes the green color. So what is the IP address? Is 4.1. Finish. Next, the research room. What is the fast Ethernet? 0/0. All right. Make port status up. Then what is the IP address? 3.1. Finish. So once we done everything, we try to check whether the system has successfully pinged within the network or not. What is mean by ping? P means packet, IN means internet, G for grouper. Packet internet grouper. How to check in the simulation tools? You can see here the arrow mark. When I click the arrow mark here, there is a small box open. This is the place we have to check the result. So what kind of the result that we have to get? When you try to ping from one system to another system, here it shows either successful or fail. That's all. It won't show any other thing. Okay. fail or success. So how to check? Now you can see here the envelope symbol, right? You click the second one, Now I want to ping from CEO to server. So CEO to server, when you click the first time, it shows fail. Just you refresh the symbol, it shows success. All right. I want to do in the reverse, server to CIO. When you do the first time, of course, it shows a fail. Just you refresh, success. Okay. So this is the one way we can check. Let me try from laptop in the research room to technician laptop. Refresh first time. Okay. Then you can try PC to printer in a progress. You see success. You don't bother about what they mentioned here. It's showing what types of protocol using between the source to the destination. All right. Now, again, I will try CEO to the same server. Now you see it shows success. I no need to refresh because the first time it take a few seconds to reach a data. Reach a signal from source to destination. But the output is working based on how the user playing in the simulation tools. All right. Okay. Fine. Now I want to connect these two routers, block A to block B. So what we do? We need to do a routing config. So how to do the routing config? We should use the cable connect between the router serial DCE. You can see here, this is the cable. Select the cable, go to the CSK router and you select the serial port. Then you go to opposite RCB router, click and connect with only any of the serial connected. After you connect, you need to set the IP address 192.168.100.1 for CSK router. The RCB router 192.168.100.2. Finish. Okay. So now what I'm going to do, assign this IP address in a router. Click the CSK router. All right. In the CSK router, you find what is the serial? SE means serial port SE2/0. You find where is SE2/0? Here. Then make a port status up. What is the IP address? 192.168.100.1. Finish. Close it. Do the same thing in opposite side. What is the IP address? 100.2. What is the port? Serial 2/0. You may ask me, shall I connect with the serial 3/0? Of course, you can connect, no problem. Make a port status up. Now you can see the green color. So 192.168.100.2. Finish. Right? So now both the router has been connected. We haven't started the routing config, but now I want to check whether both router has able to ping or not. Success. I want to do in the reverse. RCB to CSK. Fine. Perfect. But I want to ping from CEO to technician room. Okay, first time it's showing fail. Refresh, in progress, fail. Okay, let me try from research room to server, fail. All right, refresh, again it's fail. Why? Because we haven't done the routing config, which means the signal can pass within the network. Here, totally 3 networks are available. All right, inside the router 1, another block between the router. So totally 3 networks are available. So what we are going to do now, we are going to do the routing config between the routers. So how we are going to do? Before going to do that, let me explain briefly about the routing config. There are 2 types of routing config. One is the static, other one is the dynamic. The dynamic is always automatically can do, but the static we need to do manually. When we need to do a manually, we have to follow some steps. What are the steps? destination network, shortly I can put a network ID, then subnet mask, then next hop. We need to do all these three. Okay, let's say example. Now CO department, I mean is this yellow color big boss department want to do the static routing of the destination. Who is the destination? Whatever the network connected with the RCB router. So here now let me do first destination, the research room network ID 192.168.3.0. Then what is the subnet mask? 255.255.255.0. What is the next host? 192.168.100.2. Okay, so this is the information. You hold on, let me explain you. Now from here 4.0 the same. Okay, one time finish. Then again I need to do from here finish, sorry, only two times. Now the opposite side here, let me do it 1.0 and 100.1, 1.0 and 100.1. Then one more time, let me explain you after I type the IP address. Give me a few seconds. 2.0, 100.1. Okay, fine. So you can able to see the two tables. First, you click the RCB table router. From this router, already there are two departments are connected with the RCB router. So don't bother about that one. For this RCB, for the CSK router, which one is the destination? Research room and the technician room should be the destination. So we should get the information about the research room and the technician room department. So what are the things we need? We need a network ID. We need a subnet mask. We need the next hop. Okay. So now let me click the router, CSK router. You go to static. You see the routing static. Click the static. When you click the static, please you refer only this first table. So what is the first thing? Destination network ID for the research room. So what is the destination? 192.168.3.0. Press the tab button. Then you type the subnet mask. According to the IP address of the network ID, you type the subnet mask. Then next hop. Next hop 192.168.100.2. Why they are telling us the next hop? You see, just you are standing in the CSK router. You want to do the static routing of the research room. So you know the destination network ID. You know the subnet mask. Then the next hop is nothing but the data is traveling by using this red color line. So traveling, reach the destination router. When it has reached the destination router, of course, the first interface is called as the next hop. Here, what is the first interface? SC2/0. What is the IP address of the first interface? 192.168.10.2. So that is the one I typed in the next hop. Then after click the add button and make sure it should be available in the table. So from the RCB, from the CSK, we done the research room. What is the second one? Technician room. What is the network ID for the technician room? 4.0. So just only change the destination network ID 4.0. There is no changes in the next hop because the same route they are using. So you don't touch the next hop, click the add button and make sure both should be available. Finish. From the CSK, Whatever the department in the RCB, done. Now you go to the RCB. You go to the RCB. Refer this table. Go to static. So what is the first one? Big boss department 1.0. Then what is the next hope now? Just you assume you are standing here. So the data is traveling, going, reaching the first external interface, which is called as SC2/0. What is the IP address? 192.168.100.1. So this is called as a next hope. Okay, now next, same server room. There is no changes in the next hope. Finish. All right, done. So we done the static routing. We done the static routing. Now, what is the next? We try to ping. We try to ping. There are two methods we can able to ping. Let me show the first easiest one. Already we done it. Select CO laptop to internal server. Yes, success. Fine. All right. Then I want to ping CIO CTO to internal router. Success. Now I want to ping from Big Boss department to research room device. So when I click the first time, it shows fail. Don't worry, just you refresh. You see success. Then you can try from there to technician room. Success. Then you can try from the research room or laptop to server room. Success. You can try from the technician room to our server room. Success. All right. So this is the one method. The second method, what you do, if you want to check whether your system has pinged with the server, you have to go in the command prompt. So let's say example, technician here. Suddenly the big boss department are informing, hi guys, one of the system is not working in my department as well as I cannot able to access the server. So immediately the technician, take example, the laptop is the technician checking. What they're checking from the technician system to the big boss system as working or not. How they do. After you click the system, go to command prompt. Here you have to type ipconfig and ipconfig is nothing but we have to check the system IP address. Whose system? The technician system IP address is a correct or right or wrong. Please you check the version 4. Forget about the version 6. Version 4, subnet mask, default gateway. Everything is fine. All these are just now we are assigned for this laptop. Okay. Now next, what is the next? PING. I want to check the system has ping or not. Packet Internet Grouper, single space. The CEO office, the destination system IP address, you need to type 192.168.1.2. Okay. Ping the destination this system. Now you can see reply from. You can start from here. You can see pinging to the destination device with 32 bytes of data, 32 bytes of data. 4 times reply. Maximum here in the CMD command prompt, it will show 4 times. Reply from the destination system, 32 bytes, taken time 14 ms, and TTL, time to alive, is 126. So 4 times successful. Here you can see they're given us some statics. What they're given as statics, totally 4 times packet sent. Out of 4, 4 should be received. Loss is 0%. You may ask me, maximum, if you want to success, how many percentage should be here? Here, 2 out of 4 is success. 3 out of 4 is success. 2 out of 4, which means 50 and above is success. Below 50 is a fail, which means 1 out of 4 is fail. So this is the another way we can check. Now let me try from another PC or from here, research room to server room. Go to command prompt. Always you check first whether your system IP default gateway, everything is perfect or not. Then you go ping. Then the server IP address 192.168.2.3. Second router server. You see, yes, all should be successfully working. In case if I given the wrong IP address, what will happen? Let me type wrong IP address 2.7. 2.7 is not available here. So what will happen? Request timeout. All right. So second time trying, out. Third time trying, out. Fourth time, final one, trying, out. Okay, maximum 4 times. So which means maybe the system not being appropriately, or we logically we made a mistake. Maybe the IP address given wrong, default gateway given wrong, something static routing we are not given appropriately. So this is the way we have to check whether the system has a ping or not. I believe that you all are sitting in your lab system. After this session, please you can try go to command prompt. You just type ipconfig and you check your system IP address, default gateway, everything. Okay, so that's all about the session. The conclusion of the session is you people should able to know how to set up the network by using the simulation. Whatever we are select the device, whatever we are select the cable is called as, once you set up, it's called as a physical topology. Then when you set the IP address, a default gateway, network ID, destination ID, next to hop, all is called as a logical setup. So without that physical and a logical setup, we cannot make a appropriate network and design. Basically, there is a performance. They will check about the network designing performance. First, they will check the physical setup. Second, they will check the logical setup. So once the physical setup is perfect, then the logical setup is not perfect. The network cannot able to work appropriately. If the logical is perfect, physical is not perfect, also it will give us some kind of the error. So both should be make it into 100% appropriate to success the network. All right. So this is the session I want to share to you all. All right. So everything is working perfectly. If you have any question, please you can ask me, or else I hand over to the the person session in charge. Any questions, students, please you can ask me in the private chat, or you given your comment, sure I can reply to you. Okay, if no questions, the in charge of the session, ma'am, are you there? Hello.
Hello. Sir, can you hear me?
Yeah, I can hear you. Yeah, fine.
So thank you, sir. This will be the great eye-opening for the students. Now I call Mr. Hemachandran to deliver the vote of address.
Okay.
Ready, Hemachandran?
Okay, ma'am. Okay. A very good evening to one and all gathered here. I'm Hemachandran, Joint Secretary, Association of Information Technology. On behalf of all students and faculty members, I'm glad to be here to express my vote of thanks on this auspicious occasion. Let me first start with thanking the Almighty God for making this event a just a minute. Let me first start with thanking the Almighty God for me. Okay, okay, ma'am. Almighty God for making this event a resounding success. Then I sincerely thank our chief guest, Dr. Kamalakannan Mechap, lecturer, School of Technology, Asia Pacific. I'm sorry, ma'am. Sorry. Then I sincerely thank our chief guest, Dr. Kamalakanan Machap, lecturer, School of Technology, Asia Pacific University, Kuala Lumpur, Malaysia, for taking time from their busy schedule and gracing the occasion with their warm presence. It's indeed a great honor for our department to have welcomed such prominent guests who known for their great achievements in their respective fields. I want to express my profound gratitude to our founder chancellor Thiru A.C. Shanmugam and president engineer A.C.S. Harun Kumar sir for their continuous guidance and pillar of support in organizing such events. I thank our HOD Dr. N. Kanya for always supporting and guiding us. I thank Mrs. Padma Priya, Assistant Professor, Department of Information Technology, for her effort in organizing all the events successfully. Last but not least, I thank all the students, faculty members of the department, association office bearers, and non-teaching staffs for their cooperation in executing all the events successfully and impeccably. Thank you.
Thank you, sir. We'll quit the session.